there, class. Grade 5. This is Guru. I have actually kidnapped Mr. Boolsen for today, and I am instead going to be teaching your math lesson. Now, I think I picked the wrong math lesson because this one has a lot of drawing and squares, and I'm not so good at the math with the drawing, so I brought here a minion to help me. We'll see what he does. He probably will end up just sitting still there looking at you, but he's watching you to make sure you're working, at the very least. Okay, so to start, before we get ahead of ourselves, I just thought we'd start out with some pretty simple stuff, just to start our brains warming up a little bit, nothing crazy or anything like that. So if we did 5 times 5, what is that? 5 times 5? We don't know, is it? It's not coming out the clearest. I'm trying a new marker. Anyways, 5 times 5, what does that equal? Let's think about it. Give you one more moment here. Okay, it starts with 2, and then it's 5. 25. Look at that. Perfect. Now, if I were to give you, let's say here, 2 times 6, what does that equal? So you have 2 6s basically together. What do you think that equals? Yeah, you're probably right if you guessed or knew 12. And then one more for good measure. 3 times 4. What do you think that one is? Sorry, these are like block lines. 3 times 4 equals okay, so here it is. It equals 12. And so just because we're going to be drawing a lot, I'll also draw a little bit more anyways, just to help. When we say 5 times 5, what are we actually saying here? Because today's lesson is actually times as many, so we have to think about that a little bit. What is happening with 5 times 5? Would there be a way that we could draw it? I'm sure that you might have done this in the past. The way we can show it is that if you have a box of 5 or a group of 5 and you say this is a 5, you're just saying that there are 5 of those boxes. Really, is what you're saying. So you just say 5, 5, you'll have to trust me that there are 5s inside of there, and then one more 5. Now, if you said 5, 10, 15, 20, 25, and you'll get the same answer, right? So you get 25. Here it's even, oh, what's going on with my camera? Okay, there we go. Here it'll be the same thing. If we have 2 boxes, I'll try and make these boxes a bit bigger, of 6, what we really have is 12. You see that? And here would be 3 boxes of 3. I mean, well, no. Anyways, we could do that. That's another way of looking at it. 3, 3, and 3. And then you'd have a total of 12. So anyways, that is just that. We'll move into the actual lesson for today, which works with these boxes. We're going to do a lot of boxes things. Okay, so to start off, we're just going to think about these 2 boys, Sam and Ray. I don't know where they're from, but they have nice names. Ray like a sun ray and Sam like a sandwich. But which is all we need right now in these quarantine times. So anyways, what we're going to say is that, let's say that Sam has 4 times as many cards as Ray. So what would be 1 times? If someone has 1 times something, it's just 1. So we would just say, we don't know how many this times is yet. We'll get to that. But it would just be 1 box. And if we had 4 times as many boxes, what would that be? Well, what's 4 times 1? 4 times 1 is equal to 4. So you would just have 4 boxes here. Now this is always the case. No matter how many times, whatever number we put in there, it'll always be this ratio, that if it's 4 times 1, then that's how many bigger. You'll always have 4 to 1. So if he had, let's say, just for the sake of it, he had 5 cards, Sam would have 5 5, 5, 5. And so then we know that how many are these? We can add them up or we could times. We could you could take 5 times 4, which would be, you could just write it here, 5 times 4, and if you know your times table, you just say 20, or you can count it, 5, 10, 15, 20. And this one's really hard, 5 times 1, okay, take a deep breath, okay, 5 times 1, 5 times 1 is equal to 5. Bam! So that's what you have. You have a total. And then we could change this up. We could say, like if it was 7s in here, maybe we'll say that it is 4 to 1 still. These boxes might be too small for me to write in. But let's just say they're each filled with 7. What would we do? That's a bit, I need to zoom in a bit. Well, okay, you guys will have to deal with it for now. But if you have 7 times 4, what is this? 7 times 4. You have 7, you have 14, you have 21, 28, right? 28, and if you have the 7 by itself times 1, it would be just 7. So we can see, and this could happen with anything. As long, if you're saying, starting off with, he has 4 times the amount, so that would be the idea. And that we can show it in another way. So if you could get your books out today, your homework or your schoolwork, I guess, I don't know, will be on pages 14 and 15. So just please go to those pages and take a look. So I'm going to help you out with question 1b. So it's the second question there. So the first one was already done for you. This is the second question. So just take a look. It says that there are 5 blue marbles. So we have 5 blue marbles. 5 blue, we'll just say M, well, marbles. And it also says that there are 4 times as many red marbles. So what this means, guys, is that there are 5 blue marbles and there are 4 times as many red marbles. So that means that there are, if there is 5, so we can do it just like this. So if we said, if we went, we'll make the same drawing, because that's what these ones want you to do. You have to draw it. So you say blue, you say red, and then we know that it's 4 times as many. So we can start off by just drawing boxes without any numbers in them, just to show 4 times as many, right? And here we go, 4 times as many. And now we can say that these are worth, each are worth 5. You can see 5, I'll put the 5s up here, 5, 5, 5. And so in your little workbooks there, this is kind of what you want to show. You want to show the red ones and the blue ones. Now you'll have to do questions C and D as well, and then send them in to show that you're understanding this. So that's that, and I can show you also for part 2, just to help you out here. Part 2, we'll look at part 2b. So what does part 2b say? It says Randy studies rats and hamsters. She has 7 rats and twice as many hamsters. How many animals does she have altogether? So this question is looking, it adds an extra step. So we could look at it here just to start, to get the extra step. If we had 5, 10, 15, 20, this is equal to 20, and this is equal to 5, and I asked you how many marbles in total we had, what would the answer be? And I'll give you a second to think of it. Okay, so if we add these together, the 20 plus 5 we get 25. So that's all it's asking. All together, how many together would this be? So in 2b, it's asking for us to do something like this and also add them together. And so that's what you have to show. And they give you a few lines to do this. So to start off, we just need to take out what we know. We know that there are 7 rats and twice as many hamsters. And 2 times, twice means 2 times as many hamsters. I wish I could draw a hamster, that'd be so funny. So 7 rats and 2 times as many hamsters. So what does that mean for us? So when we're here, this is 4 times as many. This time we want to draw the blocks for twice as many. So what does that mean? That means that for every 1 block that you have of rats, which you want to write here rats, you're going to have a certain amount. Oh, okay. Hamsters goes a bit further. Let's just move this block out to here. So how many, if you have twice as many blocks, if you have 2 times as many as 1, how many do you have? And you would have 2. And then if you say that this is 7, then you look here and you get 7 and 7, and you're going to end up with having 14 here. So this is 14 and this is 7. Now the big deal here is you just have to add these together. You just plus these together, do addition. So what is that? That's 7 plus 14. And if I'll give you a moment to think about this. So 7 plus 14, and that is 21. So we see how that works. That's pretty neat once we get the hang of that. So and really this one you can kind of work through quite quickly, I think, these ones. So all you have to do for this one again is do C and D, and that should show that you understand this. And you can watch this again and again to look at how this works, or you can get your parents to send me a message if there was something confusing in the way I said this, because I am recording these videos and it's a bit weird to talk to myself, but I am trying my best here. So the next part for us is solving when the larger number is given to you. So in these ones, we've been given the smaller numbers. So you see we were given first raised numbers, so 5, and then we said, oh, there's 4 times as many. Or here we were given 7 rats, and we know 2 times as many. So what happens if instead of that they gave you the bigger number and they said that there was that she has 4 times as many, or they have 4 times as many? So I can show you an example here. So what happens if let's say this girl Tasha, she has, let's say she has 20 stickers. Yay, nice little, looks like a stamp almost. Anyways, nice little stickers. Nice little animal on there, I don't know what, something. Anyways, she has 20 stickers of some sort. And that means that she has 4 times as many as Eric. Eric doesn't collect many stickers. But she has 4 times as many stickers as Eric. So again, we can do the same thing. But this time, what we know ultimately, so we know 4 times. We've done 4 times before, so we can draw the 4 times. That's fairly easy. So we can do that. So we always want to make these models in this part here. So we draw these 4 squares and 4 times. So we know that's 4 to 1. So, and this time we know that all this equals 20. So we basically have this part before we have anything else. So if we have 4 things that are all the same, each one of these boxes, just like in this one it's a 7 and a 7, and this one's a 5, 5, 5. If this is 4, if all 4 of these together equal 20, what are we going to do to figure out the number? Now you can kind of cheat and look up above because we've got this number 4, but I want you to be able to think about this. So you have to do is if 4 things added together equal 20, what you can do is you can divide them. You can divide this by 4, and that will give you, I'll let you think about it, but you probably have looked up ahead, and that is 5. And so if every one of these is equal to 5, then this one is also equal to 5. And then you've figured out the puzzle. So we can know how many stickers Eric has. Eric has 5 stickers, if that's the question. So I can show you this in part 3. Let me just erase this bit of this for us here. And remember, you can pause the video anytime to get down to things. So I'll just erase some of this just so that we can keep working here. So this one is for 3A actually this time. We'll work on 3A because it's not all given to you. So it says there are 24 mangoes. And then there's 4 times as many mangoes as avocados. Sorry about that. Avocados. And so this is similar to the last one. So we know that there are, the work says it does it like this. It goes mangoes, and it has a 24 here. So that's what they want you to do. Put it beside, and it's on a line. And then there's another line here, and you can just say avos. Oh, there's the dots there. And so we're trying to figure out this number is basically what we're doing. And we know 4 times as many, so we've done this a few times now. 4 times as many is drawing these 4 boxes. And then here we just have the 1 box because 4 times as many is 4 to 1. So if we have this, we're knowing this is 24. So we have to kind of figure out what 4 numbers go into 24. And so the easiest way to do that is division. Some of you might know your tables there, or you could do a long division. So I'll give you a moment if you want to go through that and figure it out. And my other advice is always, if you want more time to work on this, is to pause the video, and then you can do it. Anyways, so the thing is that 24 divided by 4 is 6, because 6 goes into 24 4 times. So if you go 6 plus 6 is 12, plus 6 is 18, plus 6 is 24. And so that means that each one of these blocks is worth 6, and this one, being a quarter of the amount, is worth 6. And so there you have your answer, 6. So when you're given the bigger number, when you're given the smaller number, you multiply it. And the opposite, as we talked about in other videos, of multiplication is division. And so if you're given the bigger number and you want to find the smaller number, you divide it. So that's that. And now we just need a few more just so you guys are prepped to do your work for the day. I know some of you probably are ahead or have already tuned out, but for anyone who still needs to figure out, there's some kind of tricky things that are given still. So I want to go over solving when the difference is given to you. So solving when the difference is given. So sometimes the total is being given, sometimes the smallest number is being given. Now we want to know, how do we solve when the difference is given? because that's a whole another game there. So when the difference is given, that is like me doing this, and I can show you this. So there's a few questions on your board, especially in question 4, and there's some word problems as well in question 5 where you get the difference given to you. So that is a whole new thing. And the difference, we will take this one for now. So if I tell you that the difference here of these is 18. So all 3 of these equal up to 18. What is an individual block worth? So an individual block, if we know that 3 of them make 18, we can just divide the 18 by 3, because there's 3 things making up the 18. So we just divide it by 3, and we'll get it. And so 18 divided by 3 is 6. So there you go. And then if you had another one, maybe instead we I'm just going to start making them circles, because circles are easier to draw. And we just said that this many of these circles was 15. What would we be working with? Well, if 3 are going into 15, if we know that this 15 is made up of 3, we just divide it by 3, and then we'll get what it's equal to. And that is 5. So that's pretty cool. So that's how you could get the individual if you're just given the difference. Now there's a word problem in question 5 that does this. So basically we get the kind of the ratio in question 5. I'll do 5a even though it's given to you, just to explain it to you. So we have J, who he has 3 times as many cards as Sam. Maybe it's this Sam, but we don't know. So maybe it's a different one. So anyways, and we also know that J has 12 more cards than Sam. So what's 3 times? 3 times would be just like in the 4 times one. Well, different because it's 3 times. So it's 3 and 1, because that's 3 times bigger than the 1. And so we know the difference. So here we'd say, okay, so this is the difference, right? These are extra. We can see that. Those ones are the same, they equal, but there's extra, 2 more. And this is 12. So here we would say, okay, there's 2 more. And this is where these like squares kind of help you visualize it, right? This helps organize all this. And so for 12 and 2, we can say, okay, look here, 12 divided by 2 equals 6. And then you can find out how many cards Sam has. Sam has 6 cards. And you can find out how many J has by doing 6 times 3. And that equals 18. And you say J has 18 cards. And so there we have it. The last one I want to show you guys is, well, actually, I think that would be good for now. I think if you guys have any other questions, the next few questions are kind of difficult, but especially question 6, I'd understand it's a little bit complicated, but it's very similar, the same process, but work your best and try your hardest, and I hope to see you again for another math lesson. Guys, I'm sorry that I gave up with the groove voice, but you know, I try my best eventually at math. The importance of teaching you actual math is more important than the funny voice. So maybe as I get better at doing these whole videos, I can do the voice the whole time. But for now, that's all folks. Cheers!